Morning friends. Today we are going to start the topic polynomials. But before we begin the polynomials, if you remember in class 8 you have studied the topic algebraic expressions. In that topic you have seen the operations like addition, subtraction, multiplication and division. In this topic we will see some basic terms and then we will see what are the exercises and they are based on which identities, because in this topic most of the sums will be based on the identities. Half of the identities you have studied in 8th standard. Some of the identities may be new for you. We will see those identities as and when we move further. Friends, we will see some basic terms before we move to the first exercise. Some basic terms. The first term is variable. What is variable? A term or a quantity which can take any real value in particular situation or in a given problem is called variable. Its value can keep changing. Variables are denoted by x, y, z, etc. Second term is constant. A term or a quantity whose value remains same throughout a particular situation or in a given problem is called constant. Let's see the examples. So here we get the meaning of variable also and the constant also. 2x, 3x, 5 by 2x, where 2, minus 3 and 5 by 2 are constants, and x is the variable. We will see the third part, algebraic expression. A combination of constants and variables connected by some or all the operators plus, minus, multiplication and division is called an algebraic expression. You can see the example here. 2x square plus 5x minus 3. Second is x raised to 4 minus 5x cube plus x square plus 2x. Means basic operation should be there. Either it can be 2, 3 or more than that. Which are the basic operators? Addition, subtraction, multiplication and division. Right? Now we'll see what is the meaning of polynomials. Any algebraic expression that has only whole number as the exponent of the variables involved is called a polynomial. Example, 3y square plus 5y plus 7 is a polynomial in variable. Second example, x square plus 3xy plus y square is a polynomial in two variables, in x and y. In the first part, it was only one variable, that is y. In the second example, you can see there are two variables, x and y. So it is a polynomial in two variables, x and y. An algebraic expression will not be a polynomial. When it will not be polynomial? If it contains, number 1, any terms with fractional exponent. Any terms with fractional exponent. Second part, any term with negative exponent. We'll see the example here. Root x plus 1. How root x is written? X raised to 1 by 2 plus 1. Is not a polynomial because the exponent of x, you can see this x. What is the exponent of x? Exponent of x is 1 by 2. X is called as base. X is called as base. and this 1 by 2 is called as exponent, and x raised to 1 by 2, this full part x raised to 1 by 2 is called as exponential power. Again I repeat, x raised to 1 by 2 is called as exponential power, in which x is called as base and 1 by 2, it is x raised to 1 by 2. 1 by 2 is called as the exponent. So again I repeat, root x plus 1 is equal to x raised to 1 by 2 plus 1 is not a polynomial, because the exponent of x is 1 by 2, which is not a whole number. Whole number means what? 1, 2, 3, 4, 5, 6, 7. Okay, they are called as whole numbers, including 0. Right? Second example, x plus 1 upon x is equal to x plus x raised to minus 1. In 8th standard, you have seen the identities, exponents, laws of exponents. So 1 upon x is x raised to minus 1, or even we can see x raised to minus 1 is 1 upon x. This is the law of exponent. Law of exponent. It means you should know all the laws of exponents. Is not a polynomial because the exponent of second term, here in the polynomial, second term is what? X raised to minus 1. Of second term, x raised to minus 1 is minus 1. So we have seen here, okay, that when algebraic expression is not a polynomial. Now we'll see what do you mean by terms and coefficients of a polynomial. Let's see what is the definition. The various parts of a polynomial separated by plus or minus operators. Operators means sign, okay, are called its terms. Each term has a coefficient. Each term has a coefficient. We have seen the meaning of coefficient. Let's see the example. P of x. Polynomial is written this way. Polynomial is written as P of x or Q of x or R of x. How you read this? P of x is equal to 2x raised to 4 plus 3x cube minus 4x square plus 5x plus 2. So P of x has how many terms? 5 terms. See here. This is the first term, second term, third term, fourth term and the fifth term. Fifth term is constant. But altogether how many terms are there in P of x? 5. That is, first is 2x raised to 4, second is 3x cube, third part is minus 4x square, fourth term is 5x and fifth is 2. Coefficient of x raised to 4 is 2. See here, x raised to 4. What is the coefficient? Coefficient means number. The coefficient of x cube. What is the coefficient of x cube? 3. The coefficient of x square is minus 4. You have to take the sign also. What is the coefficient of 5x? 5. And what is the last term? 2. And the constant term is 2. Friends, these terms are very important, okay, before we solve the exercise. Once you understand the concepts and all these terms, you will be able to solve the exercise very easily. So you have to be very attentive, okay, when these terms and definitions are taught along with the examples. Now we will see what is classification of polynomials. Polynomial is classified, okay, into 3 parts: monomial, binomial and trinomial. Monomial means what? Having single term. Binomial means having 2 terms. Trinomial means having 3 terms. Let's see, okay. These are the types of polynomials: monomial, binomial and trinomial. And these are the definitions and examples. Monomial. What is the definition of monomial? A polynomial having only one term is called as monomial. The examples are 3x minus 5x square, 11y cube, u raised to 4. You can see here, okay. It has only one term. It has only one term. That is why it is called as monomial. Now binomial. What is the meaning of binomial? A polynomial having 2 terms is called as binomial. You can see the example here. P of x is equal to x minus 3. How many terms are there? 2. Q of y is equal to y raised to 10 plus 1. How many terms are there? 2. R of u is equal to u raised to 4 minus 16. How many terms are there? 2. So what is the meaning of binomial? A polynomial having only 2 terms. Now the third part is trinomial. Trinomial means 3. What is the definition of trinomial? A polynomial having only 3 terms is called as trinomial. The example, p of x is equal to x square plus x plus 2. How many terms are there? 3. See here, this is 1, this is 2 and this is 3. Q of y is equal to y raised to 4 plus y plus 5. So this is the classification of polynomials. Now we'll see what is the meaning of degree of a polynomial in one variable. We'll see what is the meaning of degree. What is the meaning? Degree of a polynomial in one variable is the highest power of the variable in that polynomial. Means if suppose example is given, so in that whatever will be the highest exponent, that will be the highest degree. Let's see the example. 3x plus 2 is a polynomial in variable x of degree 1. X means what? It is x raised to 1. So the degree is 1 because here variable is x. So x means it is x raised to 1. So degree will be always 1 of any variable, whether it is y. Y can be written as y raised to 1. Z can be written as z raised to 1. So what will be the degree? 1. In second example, 2y square minus 3y plus 4 is a polynomial in variable y of degree 2. See in the example, what is the highest degree? 2. In third example, 7t raised to 6 minus 5 upon 2 t2 raised to 4 plus 3t square plus t minus 6 is a polynomial in variable t of degree 6. Because if you look at the example here, the highest degree is 6. So this is the meaning of degree of polynomial in one variable. Now we will see the types of polynomials. There are 3 types of polynomials: linear polynomial, quadratic polynomials and cubic polynomials. Linear polynomials means having degree 1. Quadratic polynomials means having degree 2. And cubic polynomials means having degree 3. Let's see the first polynomial, linear polynomial. We'll see what is the definition of linear polynomial. A polynomial of degree 1 is called a linear polynomial. What is linear polynomial? A polynomial of degree 1 is called as linear polynomial. It is of the general form. And what is the general form of linear polynomial? P of x is equal to ax plus b. The general form of linear polynomial is P of x is equal to ax plus b, where a and b are real numbers and a is not equal to 0. See the examples. Root 2x plus 5. Second example is x minus 5 upon 8. Third is x plus root 2, etc. We can write many more terms. Clearly, a linear polynomial can have at most 2 terms. We can see a linear polynomial. See the example. How many terms are there? 2. In x minus 5 upon 8, how many terms are there? 2. So what we can say? A linear polynomial can have at most 2 terms. The second polynomial is quadratic polynomials. What is the meaning of quadratic polynomial? A polynomial of degree 2 is called a quadratic polynomial. And the general form of quadratic polynomial is P of x is equal to ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. We can see the examples here of quadratic polynomial. 2x square plus 3x minus 4. Second example, y square minus 3y plus root 2. Third example, 2 minus z square plus root 3z. What we can say here? Clearly, a quadratic polynomial can have at most three terms. We can see here. Into x square plus 3x minus 4. How many terms are there? 3. This is first term, this is second term, and this is third term. So what we can say, again I repeat the sentence, a quadratic polynomial can have at most 3 terms. And the last type of polynomial is cubic polynomial. What is cubic polynomial? A polynomial of degree 3 is called a cubic polynomial. What is cubic polynomial? A polynomial of degree 3 is called as cubic polynomial. What is the general form of cubic polynomial? P of x is equal to ax cubed plus bx square plus cx plus d. What is the general form of cubic polynomial? P of x is equal to ax cubed plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. The examples of cubic polynomials: 3x cubed minus 2x square plus x minus 1. Second example, z cubed plus 5z square minus 3z plus 2. So what we can see here, the number of terms are at most 4. Clear? We'll see now exercise 2.1 under the heading polynomials in one variable. Let's see what is the question. Which of the following expressions are polynomials in one variable and which are not? State the reasons for your answers. Means these are the polynomials. We have to see whether they are in one variable or not, and which of them are polynomials or not. So there are few bits. So from these bits we have to see that which are in polynomials and which are not polynomials. We'll see the first one. 4x square minus 3x plus 7. Yes. It is a polynomial in one variable. What is the one polynomial? X. Okay, it is a polynomial in one variable because the exponent is a whole number. Here, what is the exponent? 2. 2 is the exponent. See, is it a whole number? Yes. We have seen in the definition that if the exponent is a whole number, then only it is a polynomial. Otherwise, it is not a polynomial. And in the first example, we can see in 4x square minus 3x plus 7, it is in one variable. What is that one variable? X. And what is the power of this? 2. That is x square. Power means exponent. And exponent here in this sum is a whole number. Therefore, 4x square minus 3x plus 7 is a polynomial. Then second one is y square plus root 2. Answer is yes. Okay. The polynomial is in one variable y. The exponent is a whole number. Exponent is a whole number. That is why y square plus root 2 is a polynomial in one variable. And reason we have written. What is the reason? The exponent is a whole number. We'll see the third sum. You have to pay attention, okay? That is very important. Third sum. What is third sum? 3 root t plus t root 2. The expression is not a polynomial in this sum. The expression is not a polynomial. Reason is because see here 3 root t plus t root 2 can be written as 3t raised to 1 by 2 plus t root 2. Root t is written as t raised to 1 by not 2 1 by right 1 by 2, and look at this is the exponent 3t raised to 1 by 2 plus t root 2. Here 1 by 2 is the exponent and 1 by 2 is not a whole number, right? And the exponent 1 by 2 is not a whole number. That is why this expression is not a polynomial. Fourth sum, y plus 2 by y. Okay, the expression is not a polynomial in one variable. Reason is y plus 2 by y can be written as y into y plus 2 into y raised to minus 1. Reason is the law is 1 upon y is equal to y raised to minus 1. For this you should know the laws of exponents also. And see here, in y plus 2y raised to minus y, the exponent is minus 1. That is why, okay? And the exponent is not a whole number. That is the reason that y plus 2 upon y is not a polynomial in one variable. Now, the fifth one. Again I am repeating, laws of exponents are very important. Fifth one is x raised to 10 plus y cube plus t raised to 50. The expression is not a polynomial, in one variable. It is polynomial in three variables. Why? Because it is x raised to 10 plus y raised to 3 plus t raised to 50. We can see here the three variables x, y and t. So this expression is in three variables, not in one variable. Question number 2 of exercise 2.1. Write the coefficients of x square in each of the following. How many bits are there? 1, 2, 3, 4. We have to write the coefficients of x square. We will see, okay, what is the coefficient here? Coefficient, we are talking about the first bit. Coefficient of x square is 1. Why 1? If there is no term with any variable, if there is no number with any variable, it is always 1. So here coefficient of x square is 1, and you have to take the sign. 1 is what? Positive number. Signs are always towards the left. You have to check the signs. Signs are always towards the left. In second bit, 2 minus x square plus x cube. Coefficient of x square, that minus x square is minus 1, because here the coefficient is not x square, it is minus x square. So it is minus 1, because if there is nothing, as I have said just now, it is 1, but sign is what? Negative. So coefficient of x square is minus 1. In third case, coefficient of x square is pi by 2. The sum was pi by 2 x square plus pi. This symbol is called as pi. So here the coefficient of x square is pi by 2. See here, coefficient x square. What is the coefficient here? Pi by 2. Coefficient is always towards the left. And in the fourth bit, root 2x minus 1. Coefficient is 0. Why 0? Because the question is asking the coefficient of x square. Here there is no x square. So in fourth sum, coefficient is 0. Clear how to write the coefficients? Question number 3. Give one example of binomial of degree 35. Degree means power, exponent, and a monomial of degree 100. First I will write okay. Example of a binomial of degree 35. Binomial is what? Having two terms. I can write like this here. 3x raised to 35 minus 3. It can be anything, but the degree should be 35 and it should be binomial. Binomial means having two terms. You can write okay anything. You can write here 4y raised to 35 plus 8 also. You can take any number, but degree should be 35 and there should be two terms. Here I have written minus. If you want to take it as plus, still you can take it as plus. The second bit, example of a monomial. Monomial means what? One term of degree 100. I can write here root 2x raised to 100. Root 2x raised to 100. Even you can write okay 3y raised to 100. 25y raised to 100, but degree should be 100. It can be anything here. Even if you don't write root 2x, if you write okay 5x raised to 100, 4x raised to 100, 9x raised to 100, still it is correct because we can write n number of examples, but it should be monomial. Okay? Question 4. Write the degree of each of the following polynomials. Degree means the highest degree. Degree means the exponent. The first term is 5x cubed plus 4x square plus 7x. What is the degree here? Okay? Degree is 2 or 3. 3. Degree is 3. Because if you look at okay, the example it is 5x cubed plus 4x square plus 7x. So here the highest degree is 3. So we have to write that degree. In second sum, what is the degree? Highest degree? 2. See here, y square. In y square, what is the exponent? 2. So that is the highest degree. So we have to write the highest degree. In third sum, it is 5t minus root 7. If it is t means what is the power? Degree 1. If there is any variable like x, what is the degree? 1. If it is z, what is the degree? 1. Because if it is single term like this, then the degree is 1. Degree is 1. And 3. 3 is a constant number and the degree for the constant number is always 0. 3 is a constant term. There is no variable. So what is the degree of the number 3? 0. Why degree is 0? Because it is a constant polynomial. It is a constant term and there is no degree for the constant term. No degree means degree is always 0 for any constant term. So here for this number 3, degree is 0. So you understood now how to write the degrees of the given polynomials? Now the last question of exercise 2.1. Classify the following as linear, quadratic and cubic polynomials. That is why before the exercise only I have given you all the definitions and I have explained the meaning. Now these are the examples. We will see, okay, which examples comes under the category linear, which comes under the category quadratic and which comes under the category cubic polynomials. So what I will do in solution, I will make 3 columns. First I will write linear polynomial, right? POLY, I have written short form but it is linear polynomial, right? It is quadratic polynomials and last is cubic polynomials. We'll see now which goes okay in linear. In linear polynomials, 1 plus x will go. 1 plus x will go. See the degree. What is the degree? 1. It has, okay, 2 terms, but degree is 1. X means x raised to 1. 3t. Right? What is the degree of 3t? 1. That is that will go in linear. In quadratic, which will go? X square plus x. Quadratic means, okay, 2, having degree 2. Quadratic, right? Here, this will also go y plus y square plus 4. This will also go r square. See the degree, okay, 2. Quadratic. Yes or no? Adding cubic polynomials, which will come? X minus x cube. Cubic means what? Here, okay, it is, what is the power here? 3. What else will come in cubic polynomials? 7x cube. Cubic polynomials. So, linear polynomials, quadratic polynomials and cubic polynomials. So, in linear polynomials from this example, 1 plus x comes and 3t. In quadratic polynomial, x square plus x, y plus y square plus 4 and r square. Quadratic means 2, degree is 2. And in cubic polynomials, x minus x cube and 7x cube, right? So this way, okay, we can classify the polynomials as linear polynomials, quadratic polynomials and cubic polynomials. Clear?